Scientists detect radio signal from an interstellar object. Sounds like the start of a sci-fi movie. With 3i Atlas, that kind of headline has already fueled weeks of alien probe speculation online. But the new OH radio signal from 3i Atlas is not a beacon. It is a fingerprint of ordinary but scientifically exciting comet chemistry, and China's new data from Mars orbit helps confirm that story rather than overturn it. You have already heard the basics in earlier videos, so here is the quick refresher. 3i Atlas is an interstellar comet on a hyperbolic, one-time fly-through of our solar system, moving too fast to be captured by the Sun. It passed closest to the Sun around October 30th, 2025, at roughly 1.4 astronomical units, just beyond the orbit of Mars. Now it is heading back out, fading slowly as it leaves the inner solar system and climbs back into deep space. Along the way, 3i Atlas has been tracked by Hubble, by the James Webb Space Telescope, by large ground-based observatories, by Mars orbiters from Europe, the United States, and China, and crucially for this story, by South Africa's MeerKAT radio array and China's Tianwen-1 spacecraft around Mars. The puzzle is simple to state. If so, many instruments see a pretty normal-looking comet. Why did the words radio signal grab so much attention and spark so many wild theories? To answer that, we need to look closely at what MeerKAT actually detected. MeerKAT is a 64-dish radio telescope that measures how bright the sky is at many different frequencies. On October 24, 2025, when 3i Atlas was only a few degrees from the Sun in the sky, MeerKAT picked up two small dips in the radio spectrum near 1.665 and 1.667 gigahertz. Those frequencies match well-known ground state transitions of hydroxyl, or OH, a molecule made of one oxygen atom and one hydrogen atom. The dips appeared at a Doppler-shifted velocity of about -15.6 kilometers per second, exactly what you expect for gas traveling with the comet, rather than some random cloud in the background. So, the so-called signal is not a narrow intentional broadcast, and it is not Morse code from the stars. It is a pair of absorption lines, where cold OH molecules sitting in front of a brighter radio background remove a tiny fraction of the light at very specific frequencies. That is a textbook natural process. Where does all that OH come from? As sunlight heats the nucleus of 3i Atlas, buried ice sublimates and turns straight from solid to gas. Water molecules stream away into space, forming a giant invisible cloud around the nucleus. Ultraviolet light from the sun then breaks some of those water molecules apart, producing fragments like OH. That expanding cloud of OH naturally absorbs radio waves at the exact frequencies MeerKAT detected. Radio astronomers have used these OH lines for decades to study water production in ordinary comets in the solar system. From that perspective, 3i Atlas is not doing anything fundamentally new. At other wavelengths, 3i Atlas also shows a fuzzy coma, an ion tail, jets, and a carbon dioxide-rich composition, all classic comet behavior. When you stack the clues together, you get a comet-like orbit, a comet-like appearance, comet-like chemistry, and comet-like radio lines. Occam's razor points firmly toward a volatile-rich natural comet under intense solar heating, not toward a carefully engineered spacecraft pretending to be one. This is where China's view from Mars becomes important. China's Tianwen-1 Mars orbiter adds a powerful second vantage point that is far from Earth. On October 3, 2025, when 3 Atlas passed about 18 million miles from Mars, Tianwen-1 used its high-resolution camera to image the comet. The frames that Chinese scientists released show a bright central condensation wrapped in a huge coma between roughly 3,100 and 6,200 miles across, even though the comet itself was tens of millions of miles from the spacecraft. That is exactly what you would expect from strong outgassing of gas and dust, not from a compact metallic object or a thin sail. Because Tianwen-1 orbits Mars, it sees 3i Atlas from a very different angle than telescopes near Earth. That Mars-side geometry helps refine the three-dimensional structure of the coma and tail. Those measurements feed into improved models of the orbit that European and American teams use to plan their own observations and to understand the shape of the tail and antitail. Tianwen-1 cannot measure radio waves from OH directly, but it can measure how big and bright the coma is. That tells us there is plenty of gas and dust to generate the absorption that MeerKAT picked up. In other words, the Chinese data and the South African data talk to each other. They point to the same picture of a very active interstellar comet shedding volatile material under the glare of the sun. From Earth's side, optical and infrared observations show a brightening comet with a growing ion tail, changing color, and even a puzzling antitail, a spike that appears to point toward the sun rather than away from it. That antitail can be explained with dust physics and viewing geometry, where larger grains follow slightly different paths and line up just right from our angle. From Mars orbit, Tianwen-1 confirms that 3I Atlas is wrapped in a large, active coma. From radio wavelengths, MeerKAT nails down the chemistry by detecting OH absorption tied to water being broken apart by sunlight. Meanwhile, orbital calculations by NASA, by ESA, and by independent dynamical groups show that 3I Atlas is on an unbound hyperbolic trajectory, moving at around 210,000 kilometers per hour and destined to leave the solar system forever. Modeling of its brightness suggests a nucleus several kilometers across and an age of perhaps 3 to 14 billion years, meaning the comet likely formed in another planetary system long before our own sun settled down. When you combine dynamics, chemistry, and morphology, the evidence lines up cleanly with the idea of an extremely old interstellar comet. To keep the alien probe idea alive, you have to imagine a spacecraft deliberately shrouded in a giant artificial coma that just happens to look, chemically and dynamically, exactly like a real comet. You would also have to arrange for that object to follow a hyperbolic path that fits nicely into the statistics of other long-period comets and interstellar objects. At some point, piling on extra what-if scenarios make the engineered explanation less scientific and more like speculative fiction. It is still fun and scientifically healthy to ask how a true technosignature would look. Most proposed technosignatures are narrow-band, coherent emissions that stand out sharply from natural backgrounds. The OH signal from 3I Atlas shows up instead as absorption with frequencies, widths, and velocities that match standard molecular physics for OH in a moving gas cloud. If you were searching for an artificial transmitter, you would look for something very different in shape, in frequency behavior, and in how it varies over time. Looking ahead, 3I Atlas reaches its closest approach to Earth around December 19, 2025, still almost twice as far away as the Sun, but bright enough for modest backyard telescopes under dark skies. Radio observatories are planning follow-up campaigns to see how the OH signal fades as the comet cools and its water production drops. As the coma thins out, the depth of the absorption lines should shrink in a predictable way. That offers another clean test of the cometary interpretation. Researchers are also digging into more detailed Tianwen-1 analyses and awaiting further high-resolution imaging from other Mars orbiters and from large telescopes on and above Earth. The scientific question is shifting from, is it a probe, to, what can this one object teach us about how comets form in other planetary systems? Every bit of extra data, including China's contribution from Mars, makes the picture sharper. So here is the snapshot as of today. The OH radio signal from 3I Atlas is a classic hydroxyl absorption pattern tied to water outgassing in the comet's coma, not an alien transmission. China's Tianwen-1 Mars probe provides an independent geometric check, showing a large active coma and sharpening the trajectory and viewing geometry that feed into global models. Together with data from NASA, ESA, South African radio astronomers, and many ground-based observatories, it turns a clicky, mysterious radio signal headline into a coherent, testable story about extreme comet physics. 3I Atlas remains unusual, and that is exactly why it is scientifically valuable. We almost never get to study material that formed around another star and then wandered into our own neighborhood. The more we combine radio, optical, and spacecraft data, including China's view from Mars, the more clearly we see an ancient interstellar comet, not an alien message, and the more we learn about the diversity of worlds beyond our sun.